Hello, my name is James Pelletier. I'm a member of Suckjun Jun's lab at Harvard University, and today I'll tell you a bit about making PDMS microfluidic devices. So first step, we'll take the pipette tip in preparation to mix the PDMS, and we'll just cut it into slices. We used to mix the PDMS by hand, but we found that mixing it with a power tool is much faster and probably mixes the PDMS much better as well. That's what it looks like when it's finished. You can just use a regular blade to do that. So we just bought this at a local hardware store. The idea is the PDMS comes in two parts. There's a polymer and there's a crosslinker, and we use 10-to-1 ratio. So once you get that mixed up good, get the polymer and the crosslinker all mixed together, pour out about 9 grams onto a wafer, and then you want to spread out that polymer such that it coats the wafer evenly. The reason why we line the Petri dish with aluminum foil is because sometimes the PDMS runs over, and then it would stick the wafer to the dish in which we bake it. And the wafer is quite fragile, so gotta be careful of that. So after baking overnight, 65 degrees Celsius, the following day you can use a knife just to peel up the PDMS a little bit. Sorry, it's off screen. And then it comes right off. It's like a soft, flexible rubber. So the next thing we do is cut up the devices. Each wafer has maybe 12 devices, and then you can cut out the devices separately. They look like those little squares shown here. And the first step is we're going to take this PDMS block and seal it to the top of the device. So that PDMS slab has a device on the underbelly and then a flat surface on top. And we're going to bond the block to the flat surface. So the way we do that is with oxygen plasma. The PDMS, when it's exposed to the plasma, will become super reactive, such that when you take two PDMS surfaces and stick them to one another, a covalent bond will form. So all I'm doing here is just getting the plasma system set up. When you start the microwave, I guess it rips the electrons off the oxygen gas molecules and creates a plasma in the box. It's beautiful purple, I love it. Button 2 there is just releasing the vacuum, generated vacuum inside that chamber. Take it out, and then so now the top surface of that slab is reactive, and so is the top surface of the block. So all I'm doing here is just flipping the block upside down such that I can stick the reactive surface of the block to the reactive surface of the device. You just touch it a little bit, just make sure it sticks good. Leave it at 65°C for 10 minutes just to make sure things are set. Okay, so now next what we're going to do is peel up this device. The block's now covalently bound to the PDMS slab. We're going to use that gauge that I showed you to punch some holes. So the device has a long trench that's on the order of 100 microns wide and 30 microns deep that runs starting where I'll punch one hole down to the other end of the device, and then we'll come around like a horseshoe, and then I'll punch a hole through the other end of it. And through these holes we can infuse new buffer. So all I'm doing now is I locate the trench and then punch through to the top of the block, because you'll see eventually we're going to stick the underbelly where the devices are to a cover slip. So then that's great. It's like an aquarium. One side's a cover slip. You can look through the cover slip, see your cells in the mother machine growth channels, and then so now I'm just going to pull the coring tool back through the block. and then just repeat for the second one. Watch out for dust. We're in a wet lab, so by no means is it a clean environment. Again, plasma treat as we did for the block in this lab. Now the surface of the PDMS structure there that has the channels on it is ready to be bound to the cover slip, which we've also treated with the oxygen plasma. So here, you just want it to lay down nice and flat. Say the side of the block stuck down, and then then the rest of the device rippled up like an inchworm. That would be bad. And you can see the movie doesn't really portray it that well, but you can see if there's an air bubble. So just watch out for those. I'm just making sure everything is stuck down just fine. And then in the end, you can use a syringe to load your first buffer into the device. So the walls of the channels will have a residual negative charge resulting from the oxygen plasma treatment. And here I'm loading a buffer that's got polylysine, which is positively charged, covalently grafted to polyethylene glycol, which makes the channel all kind of slippery. So that's it. So have fun making microfluidic devices. Take care.